Good day. I'm from Group Yahoo. I'm the only member. I'm Matthew A. Mendoza, and I'm from BSEE 1A. The example or the topic that I'm going to discuss is integration of partial fraction, and the case is repeated linear factors. The reference for my example comes from the book Calculus Volume 2 by Edwin Herman and Gilbert Strang. Page 302 to 303, and here is the link. The example that I chose is integral of x minus 2 over quantity 2x minus 1 squared, quantity x minus 1 dx. So the first step is we're going to decompose this. We have a over 2x minus 1 plus b over 2x minus 1 squared plus c over x minus 1. So from our example, we have a repeated linear factor here. So that would be 2x minus 1 squared. So that is our repeated linear factor. So this is why our decomposed fraction look like this. And the next step is we're going to multiply both sides of the equation by the common denominator. So that would be 2x minus 1 squared x minus 1. So that is our common denominator. So multiplying this, we're left with x minus 2 is equals to a 2x minus 1 x minus 1 plus b x minus 1 plus c 2x minus 1 squared. So next is we're going to expand this. So we're going to expand this. So this cannot be expanded or this cannot be factored anymore, and we're also going to expand this. So we're left with x minus 2 is equals to a quantity 2x squared minus 3x plus 1 plus b quantity x minus 1 plus c quantity 4x squared minus 4x plus 1. And the next step is we're going to equate coefficients. So for x squared, so here we have 2a, so you can see here, so x squared, so 2a, and we have another one, so that would be 4c. And for x, we have negative 3a plus b minus 4c. So next is by 1, so we have a and negative b and c. So we have a minus b plus c. And the next step is we're going to set these three terms into three different equations. So doing this, so for x squared, so we have 2a plus 4c. And so if we look on the left hand side of the equation, so we can see that there is no x squared here, so that would be equal to 0. And the next is for x raised to 1 or just x, so we have negative 3a plus b minus 4c. So and left on the left hand side, so we have 1 here, so is equals to 1. And for x raised to 0 or just 1, so we have a minus b plus c, and looking at the left hand side of the equation, so we have here negative 2, so equals negative 2. And let's label these three equations. So this one is equation 1, equation 2, and equation 3. So to solve this system of equations, I'm going to add equation 1 by equation 2 and add equation 2 by equation 3. So doing this, so adding equation 1 and by equation 2, so 2a plus 4c is equal to 0 plus negative 3a plus b minus 4c is equals to 1. That would be negative a plus b is equals to 1. And now we're going to label this as equation A for now. So next is we're going to add equation 2 by equation 3. So we have here this. But in this case, I'm going to multiply equation 3 by 4 so that the c here would cancel out. So multiplying this, we're left with 4a minus 4b plus 4c is equals to negative 8. So adding equation 2 and our new equation 3, we have negative 3a plus b minus 4c is equals to 1 plus 4a minus 4b plus 4c is equals to negative 8, and that will be equal to a minus 3b is equals to negative 7. And let's call this equation b. So next step is I'm going to add equation a and equation b. And adding equation a and equation b, so that is negative 2b is equals to negative 6. So we can divide both sides of the equation by negative 2. So we have our b value, which is equal to 2. And So what we're going to do next is this b value is going to be substituted on our equation a here. So we have negative a plus 3 is equals to 1, and negative a is equals to 1 minus 3, and so equals to negative 2. So dividing both sides of the equation by negative 1, so our a is equals to 2. So for this a value, I'm actually going to substitute it to our equation 1 that we got earlier. So equation 1 is 2a plus 4c is equals to 0, and substituting it, so 2 times 2 plus 4c is equal to 0. So 4 plus 4c is equals to 0. 4c is equals to negative 4, and dividing both sides of the equation by 4, so our c is equals to negative 1. And as you can see right now, we can actually substitute these values to our decomposed fraction that we got earlier. So we now have the integral of 2 over 2x minus 1 plus 3 over quantity 2x minus 1 squared plus negative 1 over x minus 1 dx. So we can now solve for this. So by some rule, so this is what our equation would look like, and taking out the constants. So our constants are 2, 3, and negative 1. So let's take them out. So we now have this, and so we can notice that we can actually use substitution for 3 of these terms. So let's do that. Let's do use substitution. So for this term, so we let u is equals to 2x minus 1, du is equals to 2 dx, and 1/2 du is equals to dx. So for this one, so for next term, so let w is equal to 2x minus 1. For this case, we can actually still use the variable u, but it just depends on your preference. I just decided to put another variable so that I may avoid confusion. So our dw now is equal to 2 dx, and 1/2 dw is equals to dx. So for the next term, so let z is equals to x minus 1, and dz is equals to dx. So now we can substitute it to so we're left with this. So 2 integral of 1 over u times 1/2 du plus 3 integral of 1 over w squared times 1/2 dw minus 1 integral of dz over z. So we're going to take the constant out. So our constants are 1/2 here and 1/2 here. So taking them out, so we now have this, and multiplying 2 times 1/2, so that would be 1. So you can just omit it. So 3 times 1/2 is equals to 3/2. So this should be the one that we're going to solve now. So for this case, let's just rewrite first this dw over w squared into w raised to negative 2 dw. So they're just the same. So I just rewrite it. So now we can actually solve for the integrals. So the integral of du over u, so that is equal to ln u, and so the integral of w raised to negative 2, so from power rule, so w raised to negative 2 plus 1 over negative 2 plus 1, so that is w raised to negative 1 over negative 1, and over here dz over c is equals to from here, so negative ln z plus our arbitrary constant. And we're going to rewrite this one, so you can rewrite it as negative 1 over w here, and so multiplying 3 over 2 and negative 1 over w, so that is negative 3 over 2 w, and substituting our u, w, and z values that we got, so that we used to substitute, so we arrive with our final answer, which is the ln 2x minus 1 minus 3 over 2 quantity 2x minus 1 minus ln x minus 1 plus c. So that is the answer for the integration of partial fraction with the case of repeated linear factors. So that is all for the example.